Hello YouTube, this is Gaurav Sahani and welcome to my channel. The Olympic season is on. India has won a silver and a bronze medal and we see a lot more medals in our way. Well, to keep this excitement on, I am here with a new video in which I'll be dealing with an amazing dataset. Any guesses? I guess most of you would have guessed it right. We'll be making an in-depth analysis on Olympic dataset, which includes the data from Olympics conducted at Athens in 1896 till the latest Rio Olympics in 2016. So what are we waiting for? Let's get started. Well, talking about the data has around 120 years of Olympic dataset consisting from Athens 1896 to Rio Olympics 2016 as we discussed earlier. And the data was scraped from sports reference website in 2018 and has got more than 1,400 upvotes. Now talking about the features, we do have ID, name, gender, male or female, height and weight of the athletes, the team which they played, games, then the year, season, summer or winter, and n number of features. Now, this data is great for analyzing how Olympics has evolved over time, considering nations participated, games played, and many more points. So let's analyze the data and move into our coding part. So welcome to this coding part and I'll be using Kaggle Notebook to demonstrate my code. I'm using Kaggle Notebook so that I'll be having a convenience to import the data quickly. So starting with importing libraries, I'll be importing pandas and numpy, also importing some sub-libraries from plotly, such as plotly.express, plotly.graphObjects, and plotly.subplots. So let's execute this. Here I'll be importing my data set. Now this path I've directly copied from here. So I'll be executing pd.readcsv and the file path from which the data will be imported and save this into our variable df. So our data will be stored in our variable df. So let's execute df.head to get a glance of our data. Now as you can see, we have name, we have gender, male and female, age, we have team from which the athlete is playing, this we have games, we have year, we have season, summer or winter Olympics, we have city in which the Olympics were conducted, we have sports, we have events and medals. Now considering the shape, we do have around 2,71,000 rows and 15 columns. Now let's check whether we have any null values or not. So we'll be executing df.isnull.sum to check whether we have any null values. Now if you consider the null values, we have null values in age, height and weight of the athlete, and also we have null values in medals which are around 2,31,000. Now this value is actually considered because not every athlete will be getting a medal. Only the qualified athletes will be getting a medals from bronze, silver or gold. Now how to deal with these null values? Now if we consider the maximum null values, that is around 62,800, so this is around just 18 to 19% of the overall data. So what we can do is we take a mean of all three features. So we can execute df_age.fillNA is equal to df_age.mean. So whatever null values will be present will be filled by the mean of the age, and will be also executing in place is equal to true, so that whatever actions we'll be taking will be stored as permanent. Now the same will be executing for height and weight as well. So let's execute this. Now for dealing the null values in medals, we'll be filling the null values by no medal instead of nan values, and we'll be executing in place is equal to true. So let's get a glance of our data by executing df.head. Now here we can see that all the nan values from a medal feature has been replaced by no medal. And just to verify, we'll be also executing df.isnull.sum. Now we can see we don't have null values present in our data, and now we can move forward to create some amazing visuals and extract insights from our data. Now coming towards the first set of insights, what we'll do is we'll be finding out the cities that have hosted Olympic events. We'll be grouping by the cities based on the unique year values, and later we'll be sorting the data based on number of occurrences of each cities which have hosted Olympic events based on occurrence. Now here we will be taking our data frame DF, we'll be grouping by the cities based on the unique values of year, and we'll be resetting the index, and we'll be storing the data into our city variable. Here we'll be assigning the columns as city and year. Now once we are done with this, we'll be creating another feature or a column, say occurrence, in which we'll be taking a length of the year in which the city has hosted the Olympics. Now for example, Athens have conducted Olympics in year 1, 2 and 3. So the length will be 3, which will be stored in occurrence, and later we'll be sorting the values based on the occurrence, and we'll be keeping ascending as false. Let's execute this. Now here is the output, and we can see city Athena, that is Athens, have conducted Olympics in 2004, 1906 and 1896, which is occurrence as 3 and which is ranked on top. Whereas if we consider city Amsterdam has just conducted Olympics once in 1928, so it is ranked at bottom. Now coming towards the next set of insights and visuals, we'll be finding out the participation of men and women in Olympics, and also we'll be seeing a trend chart of men and women participation over 120 years of Olympics. So we'll be starting off by printing total number of athletes in Olympics. We'll be just printing length of unique IDs, and here we'll be taking number of female participants in 120 years is equal to length of data frame where gender is F, and similarly for male, that is number of male participants in 120 years is equal to df dot gender is equal to M. So let's execute this. We can see total number of athletes were around 2,71,000, in which the female participants were 74,500, while the number of male participants were 1,96,000. Now here we'll be just considering the data from Summer Olympics, that is the Olympics conducted in summer. So we'll be creating a separate data frame df summer, in which we'll be assigning df.season is equal to summer, and let's get a glance. Now before plotting a trend chart, we'll be creating a separate data frame trend in which we'll be executing this set of code. Now simply speaking, what we'll do is we'll be taking our df summer dataset which we created over here. We'll be grouping by sex and year, that is gender and year, by size. We'll be resetting index, and we'll be pivoting columns as sex, that is gender, so that we'll be having a separate columns as male and female. We'll be keeping index as year, and we'll be resetting index. So as you can see, we have got our data. We have year, we have separate columns male and female, and we can see total number of male participants in particular year. So we can see that in 1896 there were around 380 male participants, but there were no female participants, while in 1908 we can see there were 47 female participants, while there were 3054 male participants. Now coming towards building an interesting trend chart, we'll be taking all three values, that is year, female and male values, from our trend data frame and saving in X, Y1 and Y2 data frame separately. Now here what we'll do is we'll make subplots from our plot ly, and we'll be assigning specifications as secondary y-axis as true, because here we'll be comparing two axes together. Now we'll be also executing figure.addTrace as geo.scatterplot, where x-axis will be our year and y-axis will be female in our first case. Here we'll be setting mode as line plus markers, name as female. We'll be assigning some properties of our line, that is color and width, and here secondary y-axis will be false because this will be our primary axis. Now coming towards the second trace, here will be our x-axis as year, which will be constant in both of the axes. Y will be our y2, which is male, and we'll be also assigning the same values as mode as line markers, name as male, and the properties here will be changing color from blue to orange. Now we'll be also assigning the figure title as title text as number of male and female athletes over time. We'll be also assigning x and y axis titles as female and male, and let's plot the figure. Now here we can see a beautiful trend chart in front of us. Now let's synchronize the axes because the axes are different. So let's synchronize 4000 to, okay, so we have synchronized axes with us now. Now if we zoom out, we can see a clearer view. Now there are some amazing and interesting insights which we can extract from this visual. So we can see that in Summer Olympics, we can clearly see that the rate of change starting from 60s, the cultural changes found their way to sporting events and women were allowed to participate in rapid growing number of events, which is a really great thing we can see. While participation of male athletes evened out at 21st century, women are catching up and keeping improving their mark and there is rising participation. In Rio 2016, that is the latest one, we can see maximum number of participation from women, which is nearly close to men, while male participants are just 7,465, and we can see women participations are 6,020, 6,200, which is maximum out of all the data we have. And I guess in current ongoing Tokyo Olympics, the number would be almost same. Now here we'll be just comparing quickly the participation of male and female athletes in both seasons, that is summer and winter. So we'll be plotting a histogram where our data will be data frame DF, X will be season, and color, that is the hue, will be gender, that is male and female, and the color discrete map will be assigning male as orange color and female as blue color. We'll be updating layout as title and y-axis. So let's execute this. So here is the output and we can see in summer season, we can see the male participants were around 1,63,000 and female participants were 59,000. And in winter, the count of male participants was just 33,000 and female participants were 15,000. Now coming towards the next set of interesting visuals and analysis, we'll be importing Seaborn as SNS and also will be requiring matplotlib as PLT. And here we'll be plotting the distribution of age, height and weight of the athlete. So here we'll be executing SNS, that is Seaborn dot distant plot, where our DF will be selecting age from our DF, will be dropping NA values and color will be assigning as green. And here we'll be just simply assigning the title as age distribution of athletes, font size and font weight. So let's execute this. Now, if we consider this output, we can see we have maximum number of participants or athletes having age of 20 to 30, but we can also see participants who have age around 55 or 60 as well. So, of course, it is proof that age is just a number to participate in Olympics or any such events. Now the code which we use to find the distribution of age will be repeating this set of code for height and weight as well. So in case of height, we'll be selecting height from our data frame DF and we'll be assigning title as height distribution of athletes. Rest of all the values will be same and also we'll be assigning color as yellow. In case of weight, we'll be taking weight from our data frame DF, assigning color as blue and assigning title as weight distribution. So let's execute both of these. Now we have got the outputs and we can see maximum number of athletes have height from 160 to 190 centimeters. And if we consider weight, we can see the weight ranges from around 50 to say 90 kgs. Now before jumping to the next set of visuals, what we will do is we'll import another data set which is NOC regions.csv and this will store in a new variable NOC. Now let's see how this data looks like. Now in this data we have NOC, we have region and we have nodes. Now let's see what NOC stands for. So NOC stands for National Olympic Committee three-letter code. So basically any country is represented as National Olympic Committee code. Like for example, Afghanistan is represented as AFG. So basically this data gives an information about which country is represented by this code. Now what we will do is we'll merge the data frame and NOC data frame on NOC. Now since both these data have common column or common features say NOC and we'll be doing a left join. Now let's see how our overall data looks like. Now in this data we have NOC and we have region as well. Now here what we will doing is we'll be visualizing the top 10 countries having the most Olympic medals until now. So firstly, we'll be assigning the figure size as 15 by 10. Later, we'll be taking our data which we created earlier, and then we'll be grouping by the regions based on medals, and we'll be taking account of medals, and we'll be assigning n largest as 10. Now, if you want the top 15 or top 20 countries, just add the value as 15 and 20 over here, and later we'll be resetting the index. Now, we'll be plotting a bar chart in which we'll be giving the input as region and medal, and our data will be top C, that is top countries, which we assigned here, and we'll be assigning the title as top countries in Olympic medals. And lastly, pld.show, which will show our visual. Now we have got an output, and we can see that USA has bagged most medals, followed with Germany, France, and lastly we have Australia in our top 10 list. Now let's quickly see how many medals were bagged by our country India. So for that purpose, I'll be considering region from our new data frame data, and I'll be selecting India out of them, and I'll be storing this data in a new data frame India, from which I'll be taking a value counts of medals from India data frame. So this is what we have got the results. So until now, until 120 years of Olympics, we have got around 138 gold medals, 40 bronze medals, and 19 silver medals. Now coming towards some final visuals and insights. So here we'll be plotting a relation between weight and height of the athlete. So for that purpose we'll be assigning the figure size as 10 by 9 initially, where face color will be lavender, and here we'll be plotting C bond dot scatter plot, where the x-axis will be df weight and y-axis will be df height, and we'll be assigning the title as weight versus height plot. So let's execute this. Now this is the output we have got, and we can see the major amount of athletes are falling in this range. Now here we can see majority of weight of athletes range from 50 to 125 kgs, while if we consider height, the maximum number of athletes fall under range of 160 to around 190 centimeters. Of course, there are some outliers present. We can see set of data points at top right corner of our plot, where athletes fall under average height range but their weight is on bit higher side, and vice versa of course. Based on the tournaments or sports conducted, the physique of athletes may change. Like if we consider running, usually the athlete will have less weight, while if we consider wrestling or some sort of sports, there the weight of athletes may be slightly higher. Now I think we can make this plot much more insightful. How? Let's see what we can add which will deliver the same plot with more in-depth insights. Now here we'll be plotting the same plot, but instead of Seaborn, I'll be using plot.ly express over here. So here we'll be using px, that is plot.ly express dot scatter plot, and our data frame df, where x will be my weight, y will be my height as before, but here my color or hue will be sports, and also I'll be updating the layout as title as distribution of height and weight according to sports. So let's see how it looks like. Now this is what the output looks like, and the best part over here is we can see the distribution of height and weight based on the sports as well. Like for example, if I will be considering just basketball, we can see the height will range from 170 to 210, while the average weight is around from 80 or 75 or 70 to 120. Now if we compare basketball with ice hockey as well, we can see an interesting insight. We can see the height of basketball athletes is a bit on higher side if we compare the height of ice hockey athletes, while the weight is almost same for both the sports. Well, these were some set of visuals and most importantly insights extracted from this huge Olympic data from my side. Of course, there are still hundreds of insights which you can experiment and extract from this beautiful data. Well, this was all from my side and I hope this video was helpful. If you like this video, please do like and comment your reviews in comment section below. Also, you don't need to worry about code because I'll be mentioning the code link below in the video description. Also, I'll be sharing the link for the data as well. Finally, if you are new to my channel, please do subscribe. Thank you so much for watching. Signing off for today. Stay safe, take care, and bye bye.